Hi everybody. I just thought I'll make a little video about introduction to electricity. So first of all, why do we use electricity? That's because we need energy to do work. So if you just think about what looking around your homes or anywhere, we use electricity for a whole host of things. So we use it for light, for heat, we use it for movement. So the thing is, electrical energy is actually a very easy, cheap way of um, getting converted to useful forms like heat, light, sound, and movement. And so that's why we use electricity. So, how do we use electricity? And in order to be able to use this form of energy, we actually need electric circuits. And the current in the circuit actually travels through wires. So, when we draw wires, that's a symbol that we use for wires. Okay, now any electric circuit consists of, you need to have some sort of energy source that produces this electrical energy. And you would have learned this in year 10, but just making sure there are no gaps in your knowledge. So this symbol represents a cell. The long line is the positive end of a cell, and the little line is the negative end. If you connect two cells in series, that's how you draw that. Cells can also be connected in parallel. When they're connected in parallel, it's positive to positive and negative to negative, which is different from when cells are connected in series, it's a negative of one to the positive of the other. Okay, now when you have a whole collection of cells, you have what's called a battery, and that's a symbol for a battery. So in the car, if you ever happen to look inside the bonnet of your car, it's actually, the battery is like quite a big box sort of thing with a whole lot of little cells in it. So that's a battery. In the lab, we use what's called a power pack. So that's a symbol for a power pack. And the reason we have this arrow going through this is because you can change the voltage of a power pack. There's a knob that you can turn. And then, of course, you can get electrical energy from the mains, which looks like that one there, okay, on the wall. All right, okay, so that's the energy sources. And then you have to have, in order to be able to convert electrical energy from one form to the other, you have what we call energy converters, and there's a whole host of them, but these are just some of the energy converters that we're going to be learning at year 11. So we tend to refer to bulbs as lamps. So that's a symbol for a bulb or a lamp, but that's the word we use quite often in questions. So it's just a circle with a cross. You've got different sorts of resistors. Now, before I move on to resistors, lamps convert electrical energy to light. You have what's called a fixed resistor. That means its value stays the same, and that's a symbol for it. Resistors convert electrical energy to heat energy. We have what's called a rheostat or a variable resistor. This is it's got a sliding thing on the top where you can change the resistance. So anything that you can change often has an arrow. This is just for interest. A diode is one of the components in an electric circuit, and what it does is it only allows current to pass one way, so it only allows current to pass in the direction of the arrow. You've got all sorts of diodes. You have what's called the light emitting diode. So when a current passes, it starts glowing. Light emitting diodes are called LEDs, and you find a lot of them all over the place. In some switches, you have this little red thing that glows. They come in different colors, so that's what an LED is. Okay, now the next thing you also need to know is that in any electric circuits, you have to have something to control it. So you have switches, and that's a symbol for an open switch. When the switch is open, there will be no current flowing through. So in order for a current to flow through, you have to close the switch, because the moment there's a gap in an electric circuit, no current flows. Okay, Now, and the other thing that is a control in an electric circuit is also a fuse. Now, it's kind of symbol like a resistor, but it has a wire going right through. The thing is, when the current is very high, it's going to get hot, and so the fuse wire will melt. So it's a low resistance fuse wire, so it melts, it gets hot very fast. So that's what happens. And then there is one last thing, which is in order for us, here we go, measuring devices. So in order for us to get some readings and some values, so we have all sorts of measuring devices, but for now we just look at an ammeter, which measures current. That's a symbol. It's always connected in series with the circuit, so you need to have current flowing through the ammeter in order to measure it. The other one is a voltmeter, which measures voltage or the potential difference across any components. So a voltmeter is always connected in parallel. Okay, and then you have the ohm meter, which measures resistance. Now, the thing with the ohm meter is that its resistance is never measured when a component is connected to a circuit. It's always measured by itself. So not when a current is flowing, you don't measure resistance. Then it's just a component by itself disconnected from the circuit. So that kind of concludes my introduction to electricity. So bye for now.